of rigid motions, we can start performing more than one transformation or problem. It's important to complete each transformation in the order that they're given. So the first one says, graph the image of the following figure using the given transformations. And the first one is the 90-degree rotation about the origin, followed by translation of left 4, up 5. So once again, with the 90-degree transformation, the rotation about the origin, let's go counterclockwise. Since I didn't specify on here. And if we do the 90 degrees counterclockwise, the rule is that we flip and we change the first sign. So let's look at our ordered pairs. And what we have is we have that L is -3, 0. M is -4, -5, and N is 0, -4. Again, we're going to flip, and we're going to change the sign of the first. So this is going to become 0, -3, but 0 doesn't have a sign, so we don't have to change anything. Second one, M, -5, -4, change the sign of the first. Flip, can be -4, 0, change the sign of the first. And that's our first transformation, which we're going to graph. And again, I might recommend that you might want to use colored pencils. Put one of them in pencil and one of them in pen. Something like that. But when we graph this, we've got 0, -3. So here's our new L. And our new M is 5, -4. There's our new M. And then our new N is 4, 0. And the nice part about rigid motions is that we're not changing the size or the shape. This time we rotated it a little bit. And now that we've got that, let me label our N here, we can finish this problem, because what we're going to do is we're going to translate, moving the graph left 4 and up 5. So each of the points is going to go left 4, up 5. Starting at L, left 4, up 5. There's our new L. I'm going to put 2 prime marks there. From M, counting left 5. 1, 2, 3, 4, 5. Up 4. Sorry, I went the wrong way. Up, left 4, 3, 4. 1, 2, 3, 4, 5. And there's our new M. And then our N. Left 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's our new N. And there's our final result. So nothing new, but now we're putting more than one on here. And again, maybe it's helpful to use colored pencils or pens. If we look at the next one here, reflection over the y-axis, and let's follow a rotation of 180 degrees. Let's go clockwise this time. The nice thing though is, if I would have thought about it a little bit more, maybe I would have done something different, but clockwise or counterclockwise isn't going to make a difference. Because if we go clockwise, we're going in this direction, and we would go 1, 2. That would put us up here in the second quadrant. If we went counterclockwise, we'd be going this direction, we'd go 1, 2. So it still ends up in the same place, regardless of our transformation. But before we even get to the clockwise, we need to reflect this graph over the y-axis. So I'm going to draw in my y-axis. I'm going to try one more time. And hopefully your line is straighter than mine. But if we're reflecting over the y-axis, we're counting. One space from the green line for M. On the other side, one space. There's our new M. I don't know why I started at M. If I go back to L, L is 2 spaces from the green line. On the other side, 2 spaces from the green line. There's new L. N is 1, 2, 3, 4, 5 spaces from the green line. On the other side, 1, 2, 3, 4, 5 spaces from the green line. And we can start by drawing our picture. And again, all that we did is we reflected. And now what we're going to do is we're going to take that green triangle and we're going to rotate it 180 degrees clockwise about the origin. So if we use clockwise in this particular case, then what we're going to do is we're going to take our ordered pairs, and it's the ordered pairs from the green triangle, and our L is -2, -1. Our M ordered pair is -1, -4, and our N is -5, -3. And when we're rotating 180 degrees clockwise, it's the same as rotating 180 degrees counterclockwise. And the rule is no flip. Change those signs. So no flip. But we're going to change this here, and this is going to become 2, 1. We change both signs. Over here, -1, 4 is going to become +1, +4. We change both signs. -5, -3 becomes +5, +3. And now we have our new ordered pairs. We just have to graph them. So 2, 1 is our new L. 1, 4 is going to be our new M. And 5, 3 is going to be our new N. And there's our triangle. Let us see. A rotation counterclockwise about the origin, followed by a reflection over the line y = 1. Remember, when you have more than one transformation, we need to go in order. So the first part is the 270 degrees counterclockwise. When we look at this, the rule for counterclockwise is that we flip and change the second sign. So let's list our ordered pairs. And it's P, which is -4, -1. Q, which is +1, +3. And R, which is -3, -2. By the way, you don't have to list them in alphabetical order. I just oftentimes do. You just need to list all 3 of these if that's how if you do the flip and the change the second sign. So we're going to flip, and this is going to become -1, -4, but we're going to change our second sign. And no, you don't have to write that positive. Just figure out what works for you. 1, 3 becomes 3, 1, but we have to change the second sign. And -3, -2 becomes -2, -3, but we need to change the second sign. And now we're going to graph those values. And I think I'm going to switch colors on this one. The -1, 4. Here's our new P. And 3, -1. There's our new Q. And our new R is -2, 3. So there's our first transformation. Had a tiny mistake on the order pair, so let's go back and fix that. Easier for you conceivably than for me, but this is really a positive. It's -3, +2. So when we flip this around, this is going to become 2. Let's write in black here. Becomes 2, -3. So we flipped it, and then we need to change the second sign. So it's 2, 3. And I happen to graph R in the right place, even though I have my order pair wrong. I'm not sure how that happened, but luckily enough, that part did work for me. And now that we've got that, then we need to reflect this graph over the line y = 1. So remember that the line y = 1 crosses through the y-axis. It's going to be y = 1. It's going to be this dotted line right here. And once we get that in there, it's just a matter of counting. Well, our new P, that pinkish purple P, is 1, 2, 3 spaces away from the blue line. So on the other side, 1, 2, 3 spaces away from the blue line. There's our new P. R is 2 spaces away from the blue line. So on the other side, we're going to have 2 spaces away from the blue line. There's our R. And Q is 2 spaces away from the blue line. So on the other side of the blue line, 2 spaces away. Here's our new Q. We can draw our picture here. And again, maybe using colors might be helpful for you. Nothing new, but we're doing more than one. So as we get close to finishing here, it says, example 2, triangle ABC has vertices at -3, 5, 2, 4, and 2, 10. Transform the triangle ABC using the given transformations below. And again, let me stress, go in order of what's given here. But let's graph the triangle first. So -3, 5. Here's our A. 2, 4. Here's our B. 2, 10. There's our C. There's our triangle. And the first thing that we're going to do is we're going to reflect this graph over the line of the x-axis. So my wording's not very good there, but just a reminder, here's x, and here's y. So we're going to reflect it over the x-axis. And hopefully your line is straighter than mine, but it's a matter of counting. So we've got A is 1, 2, 3, 4, 5 spaces from the red line. So 1, 2, 3, 4, 5 spaces from the red line. There's our new A. B is 1, 2, 3, 4 spaces from the red line. So 1, 2, 3, 4 on the other side of the red line. There's our new B. And our C is 10 spaces from the red line. So on the other side of the red line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 spaces from the red line. There's our first transformation, but on this one we've got 3 transformations. There's our first. So now we're going to take this red triangle and we're going to reflect it over the line y equals x. Well, just a reminder here that the line y equals x goes from the lower left hand of the graph to the upper right hand graph through the origin. I tend to draw it with a dotted line. And again, I hope that yours is straighter than mine. What we're going to do is we're going to count here. So our A point, which is a little bit hard for me to see, but it's going to be, so we're going to go 1 space up and then 1 space to the right. So I think that ordered pair is -4, -4 on your paper. And then with point B, 1, 2, 3, 4, 5, 6, up to the blue line, and then 1, 2, 3, 4, 5, 6. There's our new B. And our letter C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over here on the other side, there's our next value of C. So here's our second transformation. And something doesn't seem right. And I think I'm right. It's just that the board is a little bit disoriented. So now, lastly, what we have to do is we have to rotate this graph 90 degrees counterclockwise. So once again, the rule for that is we're going to flip and change the first sign. So if we take a look at our ordered pairs here, and we're looking at the ordered pairs of the blue triangle, our A value is -4, whoops, yeah, -4, -4. And our B value is -4, 2. And our C value is -10, 2. And as we take a look at this one, then what we're going to do, we're going to flip and change the first sign. So we're going to flip and change the first sign. We're going to flip and change the first sign. We're going to flip and change the first sign. And then we're going to finish by graphing. So we have 4, -4. 1, 2, 3, 4. Here's our last A. The green triangle is going to be our answer. And again, that's where it may be helpful to have different colors. -2, -4. Here's our B. It's really 3 primes. And then our -2, -10. And there we finished with that one. So it's keeping track. That seems to be the hardest part. And again, I can recommend the colored pencils, knowing our rules for the reflections, for the counterclockwise rotations as well. This last one here we can hopefully make a little bit quicker to finish. I still have 3 transformations, but we don't have as much information given to us. A figure is fully contained in quadrant 3. The figure is transformed using the transformations below, and then it says in which quadrant does the remaining image lie. Well, the first of all, do you know your quadrants? And just as a refresher, here's quadrant 1. Here's quadrant 2. This is 3. And over here is 4. Goes in the counterclockwise movement. We're going to reflect over the y-axis. So again, here's x and here's y. And we're going to reflect over the y-axis. But before we get there, we need to have a picture. And again, what the directions say is it says a figure is fully contained in quadrant 3. So draw something in quadrant 3. I'm going to draw a right triangle. I try to keep it as simple as possible. And I guess it doesn't matter what I did. I guess I did, if I could get it to graph, 2, -2, -1. I think I did negative, and we'll do -5, -1. And then I think I did -5, 4. So I did -2, -1, -5, -1, -5, -1, 2, 3, 4. Yes. But you can draw whatever picture you want in that quadrant. Just put something in quadrant 3 and then do the transformations. So now it says we have a rotation. So again, the points that we picked, at least I picked, are -2, -1, -5, -1, and -5, -4. And we're going to do the rotation of 270 degrees counterclockwise, which means that we're going to flip. We're going to flip and change second sign. So we flip this, and we get -1, -2, change the second sign. -1, -5, change the second sign. 4, -5, change the second sign. And then we can draw our graph. So we have -1, 2. At some point in time, I'm hoping that you're going to correct me.